In this lesson, we'll be looking at completing the square, and specifically with a geometric proof. We have a quadratic equation, x squared plus 2x minus 24 equals 0. How do we solve this? Well, generally, we start with a graph. So we may graph it and put our x and y coordinates on the Cartesian graph, and it kind of goes in line with another technique called factorizing, where we'll just find the x coordinates and y and place them on the graph, so to speak. So in this case, let's do it, and we'll have a look at our factorizing. So we use our file method, so x times x, and again I'm just going to go through this as if you know it already. 6 times 4 plus 6 minus 4. So when you multiply all of that out, expanding your bracket, that should make sense. So x minus 4 equals 0, so x is equal to 4, and x plus 6 equals 0, so cancel 6 on both sides and you'll get minus 6. And that's how that would have worked for both those together, graphing and factorizing. If you have a variation, if you have difficult numbers, we'll say, if it doesn't work, you can use the quadratic formula, which we'll do in a separate video next, demonstrating the proof of that as well, with regard to what we're doing today with completing the square. So let's have a look at completing the square for x squared plus 2x minus 24 is equal to 0, and how it actually works, and how the phrase, the name itself, actually makes sense in terms of the geometric consistency. So, completing the square, we literally create a square. So we have x times x, which is x squared. Next, we have our next coefficient, 2x. So we have, again, we might be consistent, we have x as this one, and 2 here. So 2 times x is 2x. And lastly, I'm going to remove my minus 24. I'm going to cancel minus 24, so I'm going to get plus 24 across the equal sign. And that's our first start. And from here we're going to manipulate the geometry a little bit and complete the square. So again, x times x is x squared. We've divided our earlier rectangle into 2 rectangles now. So as x times 2, we're going to make it x times 1 plus 1. And again, same as previously, we have 24 as our last square there. Okay, now I'm going to put these together. So our coefficients are our x squared plus 2x. I'm going to put it together. I'm going to consolidate it. Let's have a look at this now. So we have our x times x and our 1 times x. So 1 times x, just look at the length there, 1 times x should be equal to, of course, 24. It's exactly the same. I've just moved these rectangles to be part of this almost a square. And now I'm going to complete it. I'm going to get this last little cube here. And what is that? Well, just look at the dimensions. It's 1 times 1. So it's plus 1. And I have to make this consistent with my equal sign. I have to make sure there's a plus 1 on the other side as well. And so that's where we're getting this. And we'll just go and rewrite this again. So x times x is x squared plus our 2x plus the 1 is equal to 25. If I were to rewrite that, it would be x plus 1 squared is equal to 25. And next I'm just going to, again, simplify that out. So x plus 1 in brackets squared is equal to 25. I'm going to multiply that out now, or simplify it, we'll say. So x plus 1 squared was equal to 25. I want to get x on its own. I want to remove the square. So cancel a square becomes a square root. 25. Just thinking about your roots, irrational numbers, you're going to have a plus and a minus, negative and positive version of this. So x plus 1 is equal to plus 5. And also, x plus 1 is equal to minus 5. And from there, cancel your 1 on both sides. You get minus 1, which is 4. And x is equal to minus 6. And there are two values that we factorized earlier. We've completed the square. So, just to go back to our graph, we had originally minus 6 and 4. Let's write out what we had before we solved it. We had equals 25. That was our original statement. Now, x plus 1 squared, leave that as it is. We're going to move it back over to minus 25. So cancel plus 25 on both sides. And just to make this a little clearer, these two values here, so plus 1 equals 0 is minus 1, and our minus 25, they are our minimum value in this case. And completing the square allows you to find that, and as you've seen, you are literally completing a geometric square to solve the quadratic itself. So it's another technique that can be used to find that. It's also useful in terms of the symmetry of the graph when we're trying to figure out bits and pieces along that lines with the Cartesian coordinate grid. And it just perfectly complements the different techniques that we have here and that you've seen with factorizing, and also with the quadratic formula, which we'll do next in the next video. Following on from our geometric proof on completing the square, we're going to look at a simple example. The answer is here as well, it doesn't make a difference. We're going to see how it works, and we're going to have a look at our little formula here as well. So we have a formula that's basically derived from that proof. And keep in mind what we're dealing with here. X plus b over 2 is referring to our initial coefficient and variables. So I'll just rewrite the quadratic equation there. Ax squared plus bx plus c. So a is 1 in this case, and b is 12. Okay, so let's write this down. X plus, so what do we change? B over 2, 12 over 2. You can write that out if you like. It's the answer is 6. Minus b over 2, which is 6, squared. And we still have to put in what's left. So we have a constant of minus 5. I can make it equal to 0. Okay, we retain our first part, x plus 6 squared for now, and 6 times 6 is 36. So even looking back at the answer now, just to make that very, very clear initially, that's our answer. So minus 36 minus 5 is minus 41. And to solve that, of course, you can start cancelling out terms. Cancel your minus 41. Your square becomes the square root, and your plus 6, and you'll end up with an answer there for your x value. Or maybe 2. So, just looking at what we're doing here, that's an initial easy enough answer for demonstrating that. But as we go along, you'd look at different examples describing the steps as well. And you'll see, based on what we did in the geometric proof and how it complements the other aspects of quadratic calculations, rearrangement and using the formula, factorizing and so on, you can also get a coefficient where a, which is the coefficient, is not equal to 1, so it's going to be larger, and they can be a little bit more difficult. So if you're a big fan of completing the square, good news is there's more of them as well at GCSE level or iGCSE. And further along we look at, maybe have a discussion chain on the graphs, turning points, and the various coordinates of that as well in lessons. And that is completing the square